All right, so let's do a quick review on the gas laws that we just discussed. All right, so let's do shortcuts, right? Shortcuts. Okay, so remember, guys, whenever we discuss gases, we always describe it in four things: the pressure, okay, the volume, the temperature, and the amount of gas, which is in moles. We'll call it N. Okay, all right. Now, remember in our previous discussions, guys, we have a balloon, right? So let's get a balloon, right? Which is tied up at the end. Okay. If the balloon is tied up at the end, no, there's no gas that can go in, there's no gas that can go out. Therefore, the amount of gas in moles is constant. So we can ignore N for now. So again, we can ignore N for now because again, there is no gas going inside the balloon, there is no gas going outside the balloon. All right. Therefore, we can just take out N for now. So again, guys, we're gonna look at the three variables: pressure, volume, and temperature. All right. So we looked at the relationship between those variables, and we found out that we can actually put them all together in one equation to show those relationships. And this is that equation. Okay. P1 V1 over T1, okay, equals to P2 V2 over T2. All right. So this is called the combined gas law. Combined gas law right there. See it? Okay. There's no uh, between those three, only those three, all right? There is no constant variable between those three. We know now that the constant is the amount of gas, but for now, there is no, let's say, between pressure, volume, and temperature, they're all changing. Okay, they're all changing right there. Okay, now, guys, if you look at that problem, you should see a variable for pressure, you should see a variable for volume, and you should see a variable for temperature. Now, what if you're reading the problem and you don't see temperature? All right. What does that mean? Guys, if you don't see temperature within the problem and there's no mention of it, temperature has to be constant. Don't forget, if it's not in the problem, it's not mentioned in the problem, we can assume that that variable is constant. All right. Since that variable is constant, let's look again at our combined gas law equation. Okay, the first equation right here. Okay, this is our main equation. This is our main equation. Don't forget that. Okay, so if you look at this right here, guys, so there's no t. So we can actually take out the t. So just erase the t, right? And what do you get? It's this equation. You see it? So if you take out the t out of that equation, you get that equation, and that is Boyle's law. Boyle's law right there. See it? All right. Now, what if you're reading the problem again, but this time instead of temperature, you don't find pressure? Okay. Let's say again, I'm reading that problem, and then I go, I don't see pressure. All right. Again, go back to the main equation. All right. Go back to our main equation and just take out the P. Take out the pressure for both sides. Take out the P for both sides. And what do you get? You get this equation. And this equation is technically Charles' law. You see it? And that's how you get those equations right there. All right. So obviously, let's say you read again another problem, and then you find out there is no volume. There's no V. Okay. So what do you do now? Okay. So again, go back to your main equation. Okay. So let's go back to our main equation, and let's take out V. Okay. So again, let's take out V on both sides. So what happens now is this changes to this. This is now your new equation, and that is Gay-Lussac's law right there. You see it now? So that's how we get those equations from our main equation, which is the combined gas law equation, right? So let's try it out. Okay. Oh, by the way, in this next slide, these are all the formulas that can be derived from that. And I'll teach you how to eyeball a problem and figure out which equation you need. All right. So for example, let's study this one first. A 5-liter gas sample exerts a pressure of 5 atm. What would be the volume if the pressure was 6 atms? All right. So by now, guys, just by looking at the givens, you should be able to tell whether it's pressure, volume, or temperature. So if you look at this one right here, 5L, that has to be liters, so that's going to be our volume. So we'll call that V1. Okay. So again, guys, by the way, for those who still don't know how to use this table, this box right here is where you put your P1. This is where you put your V1 and your T1 right here. Okay. This is where you put your P2, your V2, and your T2 right there. Okay. So our V1 is 5 liters. Okay. Exerts a pressure of 5 ATMs. All right. So by now, again, you should know that ATM is pressure. So that's going to be 5 ATMs. Okay. What will be the volume if the pressure was 6 ATM? So we got, again, 6 ATM. That's going to be our new pressure. And it says there, again, like I told you guys, look for keywords that tell you your unknown. What, right? What? New pressure. What will be the new pressure? New volume. So we're looking for volume right here. So that's our V2. Okay. All right. So what do you notice? If you notice, guys, there is no T in this problem. There is no T. So I actually take out this. Again, does that mean that T is not there? No, we just assume it's not there. Therefore, we just assume it's constant. Okay, that means it's not changing. Okay, all right. So we only got P and V2 is our X. All right. So look at your equations on the side. So again, guys, you always start with our main equation. Always start with this. All right. So this one doesn't have a T, so I need to take out the T. And it changes to what equation? It's this one right here. All right. And therefore, what is that equation? Boyle's law. So this problem is a Boyle's law problem. And that's how you identify what type of problem it is. So it's a Boyle's law problem. Okay. And how do you solve it? Just plug it in the equation. P1 V1 equals to P2 V2. Our P1 is 5. V1 is 5. P2 is 6. And V2 is X. This is 25 equals to 6X. And how do you solve for X? You simply divide both sides by 6. X cancels out. This is X equals to, and what is 25 divided by 6? It's 4.25. Oh, no, that's not it. 25 divided by 6 is 4.16. Okay. Or 17. All right. Oops, excuse me. Ah. Woo. All right. So, like I was saying, sorry. All right, so look at this one right here. Ooh, excuse me. All right, so what will be the unit for 4.17? So we're looking for V2, right? So what you do is you just look at the other side, and what's the unit there? It's L. Therefore, this is L right there. See it? And that's going to be liters right there. Okay. See it? And that's how you solve it. All right. What if, guys, you have the same problem? Okay. But the question was just asking you, which is the equation you're going to use? All right. You just do exactly the same thing. Now, look. Again, guys, let's just do this really quickly. All right. So it was P1, V1, T1, right? And we got P2, V2, and T2, right? P1 was 5 liter. V1 was 5 liters. P1 was 5 ATMs. Okay. Pressure was 6 ATMs. V2 was X, and there was no T2. So we didn't have this. Okay, we didn't have this one right here. So again, this is constant. Okay. All right. So first of all, you're looking for X, and that's V2. So what you do is you look for all the equations that's just looking for V2. So which equations are those? It's this one right here. It's this one right here. It's this one right here. And I think that's it. Okay. But which one is the correct one? All right. If you look closely, guys, you're given 1P two P's and one more V. So again, if you look closely, guys, you're given two P's and one V. So which V2 has two P's and one V? It's this one right here. Okay, so it's not this one and it's not this one. Therefore, that's your formula right there. Okay, let's try it out again. Let's try a different one. All right, so let's try this problem right here. A 5-liter gas sample exerts a pressure of 5 atmospheres at 100 K. What will be the new volume if the pressure was 6 ATMs at 200 K? So again, let's do this really fast. Again, this will be the table for P1, V1, T1. Hopefully, guys, you don't have to write this down anymore next time because you already know what the boxes are for. Okay. Okay, so P1, guys, 5 liters. Let's start with 5 liters. That's going to be our V1. Okay. If the sample exerts a pressure of 5 ATMs, 5 ATMs. Okay. At 100 K, you should know that a K is temperature. Well, it has to be K anyway. What will be the new volume if the pressure was 6 ATMs at 200 K? 6 ATMs is your pressure 2. What will be the volume at 200 K? Right. If you look closely at this one right here, this does not have any uh, missing variables. They're all there. The P, the V, and the T are there. So therefore, the main equation is your equation. Again, since there's nothing missing, this is your main equation right there. And therefore, that's the equation we're going to use. So let's substitute it. P1 V1 over T1 equals to P2 V2 over T2. Okay, so what is P1? That's 5. V1 is 5 over T1 is 100. Okay, P2 is 6. T2 is V2 is X over 200. Okay, this gives me, and I'm gonna do it here. This gives me 25 over 100 equals to 6x over 200. All right. So how do you solve for x again? In algebra, if you have a denominator, you cross multiply. Okay, this becomes 25 times 200 equals to 100 times 6x. All right. So 25 times 200 is 5,000. 100 times 6x is 600x. Therefore, to solve for x, I divide both sides by 600. This disappears. X, therefore, is simply, and let's get a calculator just to be sure. Okay, it's freezing in here, and it's 8.33. Okay, and what will be the unit? Again, since we're looking for V2, this has to be L. See it? And that's how you solve it. Okay, so again, look closely, guys. Since we're not missing anything, all right, and that's the final answer. So if you look closely at that same problem, guys, and what if you're just being asked for the formula? So again, guys, you're not missing anything. You have P1 here, V1 here, T1, P2, V2 is your X, T2. Remember, this is 200K, this is 100K, this is 5L, this was 5 ATMs, this was 6 ATM. Okay, so if we look for the formula, again, just look for all the V2s first. So what is the V2s? This one right here, this one right here, and where's the other V2? This one right here. See it? But since you have, look, I got two P's, look, other than the X, all right, other than this. I got two P's, a V, and two T's. You look for the formula that has two P's, two T's, and one V, and it has to be this answer right here. And that's how you use that chart right there. Okay? All right, cool. All right. Now, wait a minute. What if you're reading this problem right here? A 5 mole gas sample exerts a pressure of 5 atmospheres at 100 K. What is the volume of the gas? All right, remember, guys, I told you, right, there's four variables, right? So this time, guys, what if the amount of gas was changing? All right, guys, if you're reading a problem, shortcut, right? Shortcut. If you're reading a problem, and as soon as you see the word mole, okay, wherever it is, as long as you see that word mole inside that problem, this one has to be an ideal gas law problem, right? So again, as soon as you see the word mole, it has to be an ideal gas law problem. And the equation that you need is PV is equals to nRT. Don't forget that. All right. So let's figure out stuff. 5 moles. Remember, guys, that's going to be our N, 5 moles. Okay. A pressure of 5 atms. 5 atms is our P at 100 K, and that's going to be our T. What is the volume of the gas? We're looking for V, therefore this is your X. All right. But wait a minute, Mr. Chua, there's still one more variable that's missing. It's the R. Guys, remember the R is a gas constant, which means it doesn't change, which means you should know this by heart. And the correct answer here is 0.0821, and the unit is liter atmosphere per K mole. Remember, that's the only gas constant we're going to use in this class. There are a couple conversions to that, but again, they're all the same. Gas constants, again, guys, they do not change. They stay forever like that. Okay, now we have all our variables and we just plug it in. So again, we're going to take out the units for now. So P is 5, V is X, all right, N is also 5, R is 0.0821, and our T is 100K. All right. So let's start multiplying stuff. This is 5x. Okay. Grab a calculator. 5 times 0.0821 multiplied by 100, and that gives me 41.05. All right. And this should be fairly easy now. How do you solve for x? Divide both sides by 5. 5 here disappears. X is equals to, and let's divide that 5, 8.21. 8.21 what? Since we're looking for volume, this will be in liters. Okay? And that is ideal gas law. So again, one more time, right? If you ever see the word mole inside your problem, okay, it has to be ideal gas law, and this is the equation that you're going to use. All right. Here we go. Finally, guys, let's talk about Dalton's law of partial pressures. All right. Skip this. Let's skip this. Let's just skip this. Skip it. All right. And let's talk about Dalton's law of partial pressures. All right. When we talk about Dalton's law of partial pressures, guys, just remember that the total pressure inside the container, okay, is the sum of the partial pressures or the pressure of each gas. So basically what you do is you just put them all together. Okay, if you have several gases inside a container, you just add up their uh, pressures to get the total pressure. All right. So if you go look at this one right here, it takes a while for it to load. You can click on that, and then you can click on that, and then you can practice on it. All right. Takes a while. It takes a while. Okay. All right. All right. So you see this, for example, guys. I got two gases here, A and B. Okay. If I put them together in this container right here, what's going to be their total pressure? For example, gas A has a pressure of 4. Okay. And gas B has a pressure of 4. Of course, when you put them together, the total pressure is 8. You see it? And that's it. So what if you have like 7 ATMs for gas A, okay, and gas B is still at 4? You put them together, guys, the total is still 11. So again, you just add up all the partial pressures, right? You just add them all up and it gives you the total pressure. All right. So let's do a sample problem. All right. And don't forget, guys, partial means part of a whole. All right. So let's try an example right here. A metal tank contains three gases: oxygen, helium, and nitrogen. Okay. If the partial pressures of the three gases in the tank are 35 atmospheres of O2, 5 atmospheres of N2, 25 atmospheres of HE, what is the total pressure of inside the tank? Okay, so it's easy. You just add them all up. So let's just call, for example, let's say our gas A is O2. Let's say this is O2, and this is going to be 35 ATMs. All right. And then N2 will be 5 ATMs. Okay. And then HE, let's call it gas C, was be 25 ATMs. All right. There is no gas D here, so you can just leave that blank. Okay. There's no gas D there. And then you just add them all up. Okay. So this is now, total is 65 ATMs. You see it? All right. So don't forget, it's just the total right there. Okay. Because you add these three up and you get 65. That's how easy it is. All right. So what if one of them was missing? Okay. For example, what if one of them was missing? Okay, a tank contains a mixture of hydrogen gas and oxygen gas. So there's only two gases here. All right, there's only two gases here. You don't need gas C and gas D. There's no need for these two. Okay, all right. So you got H2 and then O2. All right. The total pressure exerted by the gas mixture is 500 ATMs. So that's the total pressure. So our total is 500 ATMs. Okay, you see it? The partial pressure of hydrogen is 180 ATM. What is the partial pressure of oxygen? So how do you get the partial pressure of oxygen? It's very easy. You just think of a number to add to 180 to get 500. Okay? Or it's simply 500 minus 180. Okay? So you just need to figure out what do you need to add to 180 to get 500. And the answer for that one is 320 atmospheres, and that's the partial pressure of O2. All right, so don't forget. All right, and again, guys, this is called Dalton's law of partial pressure. Dalton's law of partial pressures. All right, pressures. And again, that means that the total pressure inside the container is simply the sum of all the individual uh, pressures of each gas. All right. Hopefully, this helps you out in your quiz. Good luck. All right. And if you need more help, please attend tutorials or do the practice problems and watch those videos in the lessons. All right.